This is the second video for Chapter 22, the lymphatic system. In this video, we're going to talk about immunity. So immunity is your body's ability to fight off infection and disease. Your body has two types of defenses. One type of defense is called non-specific defense. And in this defense, the body does not discriminate between one threat or another, so it doesn't discriminate against pathogens. So in other words, it's not looking for a specific pathogen, a specific bacteria, a specific virus. It's going to defend your body against any type of pathogen. The other thing with this one is that it is present at birth. Because it's present at birth, sometimes we call it your innate immunity. Innate meaning you're born with it. There are several different non-specific defenses that we're going to discuss, including your body's physical barriers, the phagocytic cells in your body, cells that provide immunological surveillance, other things like cytokines, including interferons. We're going to talk about complement proteins, inflammation, and fever. So I didn't list those here because we're going to go through each one of those individually. But the second type of defense is called specific defense. And with this type of defense, you're not born with it. You have to acquire it. So in order to acquire it, basically what you're doing is coming in contact with a particular pathogen, and then you're building up an immunity against it. So sometimes we'll call this adaptive immunity. Because in order to survive, you have to adapt to whatever pathogen it is that's trying to attack your body. In this specific defense, it depends on lymphocytes. Notice that when I was talking about all of the types of defenses in non-specific defense, I didn't mention lymphocytes. So specific defense uses lymphocytes to defend your body. And then lastly, it provides very specific resistance. So that means that your body will, it's going to respond to one particular pathogen at a time. So we'll go into that a little bit more later in this video. We're going to first start by talking about the non-specific defenses. So when we talk about the innate and specific defenses, I'm going to talk about your first line of defense and your first line of defense in your body are going to be the physical barriers that we'll talk about. So these physical barriers, these are part of your innate immune system, or your innate defense, your non-specific defense. So that's the first thing. Bacteria have to get past that first line of defense. They have to be able to get into your body. If they can't get into your body, then they can't cause any harm to your body. So that's going to be the first line of defense, and this is going to be the physical barriers. The second line of defense is also innate, and it's going to include cells and cell processes. But it's still part of the innate defense because these cells and the cell processes are non-specific. They're going to just attack anything that comes into your body. So this would be considered your second line of defense. Then if that pathogen were able to get past those cells and cell processes, then we have your acquired immunity or your adaptive immunity. That will provide your third line of defense. And so your third line of defense are going to be those lymphocytes. So whatever pathogen comes into your body, they have to be able to get past each of these in order to make you seriously ill. So here are all of the innate defenses, which are non-specific defenses. And so we'll go up to the top here and we'll start with physical barriers. So a physical barrier is basically anything that's going to keep that pathogen out of your body. It's a physical characteristic that you have that will keep those hazardous organisms and materials outside the body. So we look at things like skin. Okay, skin is a physical barrier. It's not going to let things inside. Also, hair. So hair is creating a barrier outside of the skin to prevent these organisms from landing on your skin. There's also secretions as well. So secretions such as like sweat. Sweat has a lot of salt in it, and these pathogens don't like salt. There are other glands that cause secretions, such as sebaceous glands. So if you remember, sebaceous glands secrete an oil, and the bacteria find it hard, viruses find it hard to get through that sebaceous oil in order to get into your body. And then also mucus glands. So mucus glands are secreting mucus, and inside your mouth and inside your digestive tract, it's hard for those bacteria and viruses to get through that mucus in order to get into your body. So the physical barriers here, this is your innate defenses, and this is your first line of defense. Those pathogens have to get past those physical barriers. Then everything else under innate defenses will fall under your second line of defense. And we'll start by looking at the phagocytes. Now remember, the second line of defense is cells and cell processes. Okay, so first we're going to look at phagocytes. Phagocytes are cells. When they come in contact to a pathogen, they're going to engulf it. And they don't really care what kind of pathogen it is. They don't care if it's a virus or if it's a bacteria or if it's a parasite. They don't care. They're going to engulf it. And then the lysosomes inside those cells are going to rapidly tear apart that bacteria and dissolve it. So here's the different phagocytes that we have. They float around in the peripheral tissues. They're going to remove everything from the foreign organisms to even cellular debris. So first we have these neutrophils. These neutrophils, like we said before, they are the first ones at the site of an infection, and they're going to engulf any debris that's around there from an injury or infection, and they're going to engulf different pathogens as well, any pathogens that come along. Then we have these monocytes. Monocytes are found in the blood, and they are also phagocytes, so they're going to engulf anything that comes in contact with it. And then when they move out of the blood, they squeeze out of the lining of the blood vessels through diapedesis. They then become macrophages. And there are free macrophages and there are fixed macrophages. Free macrophages are phagocytic cells that can just float around from tissue to tissue, and they'll engulf anything that looks abnormal. Fixed macrophages are these macrophage cells that just hang out in specific tissues. So we give them specific names. So for example, the macrophages in the liver, we call stellar cells. They used to call them Kupffer cells. Now they're stellar cells. The ones in the brain are called microglia. The ones in the lungs are called alveolar macrophages. So they're just given different names if they're fixed macrophages in specific areas. And then finally we have eosinophils. Eosinophils are sensitive to parasites. Sometimes the parasites are too big for the eosinophils to swallow up, so instead they'll shoot out chemicals at them and attempt to burst their membranes. Next, we have these cells that you've heard of before. They are involved in immune surveillance, and they are called the natural killer cells. So the natural killer cells. NK stands for natural killer. And so they float around in the peripheral tissues, and so here's a natural killer cell right here. And when they come in contact with a cell that looks abnormal in any way, it can be one of your cells that's infected, it could be a foreign cell, but it comes in contact with it, and then it shoots out these little bullets at the cell called perforins. And the perforins put holes in the cell membrane of that other cell, and then that other cell lyses. Okay, so the perforins cause lysis, which is the bursting of the other cell. Then we have interferons. Interferons are chemical messengers. They're in this line of messengers that we call cytokines. And when you get to advanced, we're going to talk a lot more about cytokines. They're very important. But interferons, they help to fight against viral infections. They actually slow the synthesis of viruses. And, or in other words, they slow the replication of viruses. So interferons are not cells, they are chemicals. And so here we see a cell, one of your cells. It could be a lymphocyte, it could be a macrophage, or it could even be one of your cells that have been infected by a virus. And that cell starts to release these little chemicals. These little chemicals are called interferons. The interferons then will travel to other cells, and they will slow the viral infection. Next, we have the complement system. The complement system, it assists the antibodies. So it kind of complements the antibodies. So you can remember it that way. So what antibodies do is they detect pathogens, and they detect foreign cells, and they attach to the cells, and they can flag down these macrophages. Well, these little complement proteins do the same thing. So the complement system is a system of these circulating proteins. So we can call those complement proteins. And it's a system because one group of proteins will activate another group of proteins, which activates another group of proteins. And what those proteins do is they bind themselves to a pathogen. So right here we see a little bacteria. This thing right here is a bacteria. And these little blue things here that I'm coloring in, those are the complement proteins. So the complement proteins dot themselves all over that bacteria, and then that bacteria can't withstand that, and so the bacteria just lyses. If the bacteria doesn't lyse, these little complement proteins, they act as little flags, right? And they flag down these macrophages, which will come along and will engulf the entire pathogen. Next, we have inflammation. So inflammation is a localized tissue response. So it's localized. It's not throughout your entire body. It just happens in a specific location. Inflammation is a response to an injury. So it produces these cardinal signs of inflammation, which include swelling, redness, warmth or heat, and pain. And it can also cause a loss of function. So these first four here, swelling, redness, warmth, and pain, we call the cardinal signs of inflammation. Now, inflammation is due to a cell called the mast cell. And the mast cell has these little granules that are called histamine and heparin. You have heard of histamine and heparin before with a white blood cell that we called a basophil. So the basophils and the mast cells are very similar. The only difference, or one of the big differences, is that basophils move around, so they are not fixed, and mast cells are fixed in tissues. So these mast cells release histamine and heparin, and histamine increases blood flow because it makes the blood vessels dilate, and it also increases capillary permeability, so fluid can flow out of the blood vessel into your tissues and cause swelling. And then heparin also stimulates regional clotting reactions, so it starts to create clotting. These chemicals also activate macrophages, so they will come along and start engulfing any debris. They activate the complement system, which will help to fight off any infections, any infected cells, or any bacteria that might end up in the area from the damage. They increase regional temperature. We're going to talk in a minute about what temperature does. And then they activate the adaptive immune system. So these mast cells are pretty active in the immune system. And the last thing that we have in the second line of defense, which is still part of nonspecific immunity or innate immunity, is fever. So fever is an elevation of body temperature. The well-known temperature of the body at 98.6 degrees Fahrenheit is also 37.2 degrees Celsius, and that's when you take that temperature orally. That's the average. Some people might have a little bit lower set point temperature, and some people might have a little bit higher set point temperature. But when we start talking about fever, there's low-grade fevers and there's high-grade fevers. A low-grade fever is classified as an oral temperature that's above 98.6, but is below, that is lower than 100.4. And then we have a high-grade fever, anything above 100, like 101 degrees, above 100.4 degrees is considered a high-grade fever. A fever of a greater than 103 degrees is concerning in adults. So basically, a fever is an elevation of body temperature. And what that does is it speeds up your tissue metabolism. So it's speeding up all of the enzymatic activity in your body. And by that, it's stimulating or accelerating your body's defenses. The way that I like to think of this is that these bacteria, they love 37.2 degrees Celsius. As a matter of fact, in microbiology, that is the temperature of the incubator that you use to grow these bacteria. So bacteria are very, very happy at 37.2 degrees Celsius, at least bacteria that we call pathogenic. Those are bacteria that can cause illnesses in your body. If the temperature increases above that, then bacteria can't multiply as fast. If bacteria can't multiply as fast, that means that the body has a greater chance of getting to those pathogens before they can cause any damage or any infection in your body. Now we're going to talk about the specific defenses. And if you remember, I said specific defenses deal with the lymphocytes. In other words, the lymphocytes provide your body with specific defenses. So the body's specific resistance or immunity is provided by these different types of lymphocytes. And the types of lymphocytes, if you remember, I said there are 3 types of lymphocytes. There's the natural killer cells, there's T cells, and the B cells. The natural killer cell, that is part of the innate immunity. And the T and the B cells, those are part of specific immunity. So we're going to be concentrating on the T and the B cells. They respond to, what specific immunity means is that the T cells and the B cells respond to specific antigens. So they're not generalized. They're not just saying, I'm going to protect the body against every type of pathogen or every antigen. They're saying, I'm going to respond to just a specific antigen. So in specific defenses, we have what's called cell-mediated immunity. And cell-mediated immunity always, sometimes they call it cellular immunity instead of cell-mediated. Your cell-mediated immunity is because of the T cells. So the T cells provide this cell-mediated immunity. They provide a defense against abnormal cells and pathogens that are living inside your cells. So the T cells provide immunity. When your cells are infected. So what I mean by this is that, there are cells in your tissues in your body. So these are your cells. And so this is intracellular fluid, right? And outside of that is extracellular fluid. So what I mean is that the T cells have to be infected. So either a virus has gotten inside one of the cells, or if it's a macrophage, the macrophage has engulfed a bacteria and the bacteria is now inside the cells. So the T cells are only going to respond if your cells are infected. They're not going to respond to this little bacteria that's out in the extracellular fluid. It's only going to respond if these things are brought into your cells. So we say it's cell-mediated because the infection is inside your cells. Then we have what's called antibody-mediated. And sometimes we call antibody-mediated humoral immunity. So humoral means body fluids. So these are the B cells provide this immunity. And so the B cells are going to respond to these antigens and pathogens that are out in the extracellular fluid. So here you have a B cell floating around, and the B cell has these little antibodies sticking off of them like this. And so there will be maybe a pathogen, a little bacteria or even an antigen, and they come in contact with that B cell, right? So they come in contact with it, and that's going to activate that B cell, and then the B cell is going to provide immunity. And so how they do that then is they start producing antibodies. I want to talk about the forms of specific immunity. And remember that specific immunity is acquired. So it's not at birth. So with cell-mediated immunity, the T cells, so this is a T cell, it has to respond to an infected cell. And once it responds to that infected cell, the T cell will start to divide. And when it divides, those daughter cells will start to differentiate. And they can differentiate into a cytotoxic T cell or a helper T cell or a suppressor T cell, otherwise known as a regulatory T cell, or a memory T cell. And the cytotoxic T cells will go off and shoot bullets and directly destroy pathogens. And it's very specific. So for example, if this T cell responded to this infected cell, and let's say this infected cell was, it was infected by, let's say, strep pneumoniae, then the cytotoxic T cell will only destroy strep pneumoniae. Okay, which is a cell, a bacterium, right? The helper T cells, what they're going to do is run off and activate more T cells. And it'll actually also activate the B cells. So what I mean by activate is that it will cause these T cells to start dividing and differentiating, and then it will also activate the B cells. And we'll talk about the B cells in just a minute. The B cells are going to produce antibodies. The suppressor T cells, these are the ones that mediate, or actually what they do is inhibit. They'll inhibit the T cells. And the reason why they would want to inhibit T cells is if the body figured out that this is going to be a long-term infection, it's not going to get over quickly, then the suppressor T cells want to make sure that all of the immune energy isn't being used up too quickly. So it will inhibit the T cells. This also helps your body to prevent attacking its own cells. It doesn't want the immunity, your immune system to get overzealous and start attacking cells of your body that are not infected and that just kind of look normal. So that's what the suppressor and regulatory cells are for. And then we have the memory T cells. And the memory T cells won't do anything this infection, but they are there for the next infection. So the next time the same strep pneumoniae is in contact with the body, it will mount a very fast immune system where the memory cell will differentiate into these 4 different types of T cells. It'll become the cytotoxic T cell. The daughter cells will, as it's dividing, it'll become the helper T cells. It'll become the suppressor T cells. And it'll become the memory T cells again. So it's just the memory T cell doesn't have to wait until your cells get infected. As soon as that memory cell gets is exposed to that bacteria, it's going to quickly just jump right ahead and start dividing into these other very specific T cells. So it's just going to be much faster. So the second infection will be much faster. Now let's talk about these B cells. So these B cells, first of all, they look the same as a T cell, except for they have these little antibodies sticking off of them. And so the B cells first have to be sensitized. So this, say we're still talking about the strep pneumoniae. So say this strep pneumoniae bacterium comes and it attaches itself to the B cell. So this is a B cell. Now that B cell becomes sensitized. And then that helper T cell has to come over and activate that B cell. So we have to have that helper T cell activating that B cell. Once that B cell becomes activated, it becomes a plasma cell. And then the plasma cell secretes these little Y-shaped proteins that are called antibodies. And what we saw happen with the antibodies in the red blood cells are what will happen with these antibodies of the immune system. They will find the Strep pneumoniae bacteria and they will bind to it. And while they're binding to it, that causes it flags down other macrophages to come along and engulf that bacteria, or it'll cause that bacteria to burst or to lyse. So with acquired immunity, as we think about how the T cells and the B cells work, immunity can be provided to people through either an active form or through a passive form. So active immunity means that the body comes in contact with the antigen, okay, it comes in contact with the antigen, and then it mounts an immune response. So by immune response, I mean that the T cells become activated, and that will activate the B cells, and then antibodies are produced. Now, the reason why we call this active is because it's a very active process. The body is working, right? So the body is working. It takes work. It takes work for the body to respond, for the T cells to become activated, for the B cells to become activated, for antibodies to be produced. The body is actively working to do that. In passive immunity, on the other hand, passive immunity are where antibodies are just given to someone from an external source. And we can call that exogenous. So it's coming from a medication, or it's coming through the environment. So passive just means the body didn't have to work to get these antibodies. They were given. It's like a gift. The antibodies were a gift instead of the body having to work for it. All right, so now let's look at the different types of active immunity and passive immunity. So active immunity only appears following exposure to an antigen. So we have two types. The first type is called naturally acquired active immunity. Naturally acquired active. So we have to think about, how does a pathogen naturally come into contact with the body? So this is, so naturally acquired, this develops from exposure to an antigen in the environment. So when you think about it, how do you come in contact with an antigen? Well, it's, from person to person, right? So you sneeze on someone, or you sneeze on the door handle, you sneeze on your hand and you touch the door handle. You are spreading that antigen from person to person. And so that second person then has to develop this active immunity. Their body has to activate their T cells, then their B cells, and antibodies have to be produced. So it's from exposure to an antigen in the environment. Environment, that meaning that's why it's naturally acquired. Then we have a second type of active immunity, which is called induced active immunity. And induced active means that the antigen is being administered by a health professional. Okay, so the antigen itself is being delivered by a health professional. So when we think about this, when do we give a pathogen? When does a nurse or a doctor give a pathogen or an antigen to a patient. That is during a vaccine, right? So that's what a vaccine is. So when you're getting the chickenpox vaccine or when you're given the polio vaccine, you are actually given the antigen or parts of the antigen to a person, and then their body's going to respond to it. Their T cells are going to respond to it, their B cells are going to respond to it, and they'll produce antibodies. So that's a vaccine. Whereas this naturally acquired, an example of that would be like the common cold, right? You have a common cold and you're just spreading it from person to person. Okay, so now let's talk about passive immunity. So passive immunity can also be naturally acquired or induced. So let's talk about naturally acquired passive. So in naturally acquired active, this means that antibodies are coming through the environment. They're not being administered by a health professional. They're just coming through the environment. So when would antibodies be transferred from person to person naturally? Examples of this type of immunity would be during nursing. So when a mom is nursing the baby, the antibodies come through the milk. Another example of this would be through the placenta. So when a mom is pregnant, the antibodies pass from her blood into the baby's blood. So those are just very natural processes. The second type of passive immunity is induced passive. So in this case, this is administered by a health professional. So a health professional now is administering antibodies. So instead of administering antigens, which we saw in induced active, now we're administering antibodies. So when would a person need to have antibodies? Well, induced active, when a person's given a vaccine, this is more preventative, right? We're trying to prevent them from getting this disease. So we're giving them an antigen, just a small amount, and we're letting their body develop these memory cells. So if they do ever come in contact with it, they'll be able to start and mount an immune response much faster. But in the case of this induced passive, when antibodies are administered, this means that the person is already infected, so it's not preventative anymore. Now we're actually trying to help them, and we would have to administer antibodies in certain cases when that person doesn't have enough time to build antibodies on their own. So when we look at some examples of this, so what we want to say is administered when antibodies are needed quickly. So when we think of an example of this, what about when a person has a snake bite? So they were given, with a snake bite, now they have this venom inside of them, and the venom has to be fought off by the antibodies, and the body might not have enough time to develop antibodies. So then a health professional would administer antibodies, would give them antibodies to help fight that infection off. Or in the case of rabies, right? When that rabies virus gets into a person's body, they don't have time necessarily to develop an immune response. So the health professionals have to give them antibodies so that the infection doesn't overtake their body before their body can mount this immune response. So then antibodies are given to that person. So you are going to want to know kind of the definition of the two types of active immunity and passive immunity, and also be able to give examples of each. Finally, I want to go over the properties of immunity. So this is the properties of specific or acquired immunity. And first of all, specific immunity has specificity. Specificity means that a specific defense is activated by an antigen and the response targets only that antigen. In other words, the T cells and the B cells will only respond to that one specific antigen. The second property is called versatility. So you have millions of different lymphocytes. Because each lymphocyte is only going to respond to a specific pathogen. So you have to have millions of different lymphocyte populations that have different receptors so that you are able to respond to the millions of antigens that you're going to come in contact with. The next property that specific immunity has is memory. So the immune system remembers the antigens that it encounters because it might come in contact with that same antigen, but maybe years later. So the memory cells, they enable the immune system to remember the previously encountered antigens. And then when they do come in contact again with that antigen, they can launch a fast, much faster, stronger counterattack on the second exposure to the pathogen. The last property then of specific immunity is called tolerance. Tolerance means that the immune system doesn't respond to its own cells. So the immune system ignores healthy, normal cells. If it weren't ignoring those healthy, normal cells, then we would end up with a situation called an autoimmune disease. Okay, then that ends the second video on the immune system, Chapter 21, the lymphatic system. So we will see you next time in the next video.